Okay, we've got a problem here from the homework, informing functions from verbal descriptions of problems. These are sometimes called story problems or word problems. In this case, a manufacturer wants to produce boxes with a square base and no top with 8 cubic meters of volume at the lowest possible cost, given that the material for the bottom of the box costs $8 per square meter and the materials for the sides cost $6 per square meter. So first, we want to express the cost C of the materials as a function of the width W of the base. That means we need a formula for C in which the only other variable is W, so there can't be any H's in that formula. So, to express the cost C of the box, we simply add up the cost for all the surfaces. The area of the base is W times W, or W squared, and that costs $8 per unit, or 8W squared. Plus there are 4 sides, and the area of each side is just W times H. And that material costs $6 per unit, so 4 times 6 WH, or C equals 8W squared plus 24 WH. So we have a formula for the cost C of the materials, but it's not only in terms of the width W of the base, there's also an H in there. So how can we deal with that? Well, we have some more information given to us in the problem. We know that the volume of the box is going to be width times length times height, or in this case the width and the length are the same, so the volume is W times W, or W squared, times H. But they tell us that the volume is 8 cubic meters, so 8 equals W squared times H. Now if we solve for H by dividing both sides by W squared, we'll get 8H equals 8 divided by W squared. Now what we can do is take this value of H and plug it back in where the H was in the equation for the cost. So that gives us C equals 8W squared plus 24W parentheses 8 over W squared, or C equals 8W squared. 24 times 8 is 192, so that's 192W divided by W squared, or C, we can factor out a W from top and bottom of that expression, so that gives us C equals 8W squared plus 192 over W. And that's what we're after for part A. We've expressed the cost C of the materials used to make the box as a function of the width W of the base. Now part B asks us to use a computer or graphing calculator to find the minimum cost. That is, what is the lowest cost for which this manufacturer can produce boxes with a volume of 8 cubic meters, and what will be the width and height of those boxes? To determine this, I use the Wolfram Alpha iPad app. I plugged in the formula that we arrived at in part A, that is C equals 8W squared plus 192 divided by W. And Wolfram Alpha calculates a number of things, including the minimum of the function. So we see here that the cost will be 125.796, or approximately $126 per box. And that at that cost, the width will be 2.289, or approximately 2.29 meters. We can plug that back into that equation that we had for the height and determine that the height of each box will be 1.53 meters. So for the manufacturer, those are the dimensions that need to be used to produce a box with a volume of 8 cubic meters at the lowest possible cost, which will be $126 per box.